right, students, today's notes are 8.2 and 8.3. They're over parallelograms. And the definition that we're going to write down is the same definition that you had in middle school. It is a quadrilateral with two pair of opposite sides parallel. With two pair of opposite sides parallel. All right, let's draw a picture. So if I start here, when we generally think of a parallelogram, we generally talk about or think of a slanted rectangle. It's kind of like a rectangle that's kind of been pushed over. So a slanted rectangle. All right, so if I call this one CPHS, I need to mark the sides are parallel, so I need to mark them parallel. Remember, this is how you mark sides parallel. So since those are parallel to each other with a single parallel mark, I'm going to mark these with a double parallel mark. Alright, so what that means is that CP, segment CP, is parallel to SH, and segment PH is parallel to CS. Okay, diagonal. Now diagonal we covered in the last lesson, 8.1. Remember, it is a segment connecting two non-consecutive and remember that just means they can't be side by side or next to each other, vertices. Okay, so again I'm going to draw a slanted rectangle to represent a parallelogram, since we're talking about parallelograms today. Okay, so I'm going to call this the math parallelogram, M-A-T-H. Okay, so if I identify M as my vertice, my first vertice, and I want to connect M to the other vertices, if I connect it to A, that's already the side of the parallelogram. So I can't call that a diagonal because it's a side. If I connect it to T, it's going across through the center of the parallelogram. That is a diagonal. And then if I connect M over here to H, that is also a side, so I can't call that a diagonal. So this is the only diagonal that I can draw from this point. There's another diagonal that I can draw, and choose a different color, this one right here. I can draw the diagonal from A to H. Okay, so what I should write down are MT, segment MT, and segment AH are diagonals. I'm going to change colors to make sure that you remember that these are diagonals. Okay, this one and this one. Okay, we have some facts that come from the theorems about parallelograms. The first theorem that we're going to talk about states if a quadrilateral, a four-sided figure, if a quadrilateral, Q-U-A-D-R-I-L-A-T-E-R-A-L, for those of you that don't know how to spell it, is a parallelogram, P-A-R-A-L-L-E-L-O-G-R-A-M. So if a quadrilateral is a parallelogram, then opposite sides are parallel. That's basically restating the definition. But this one talks about two pair of opposite sides parallel. Here, it's just saying that if the sides are opposite, then those sides are parallel. So I'm going to start here by drawing my parallelogram. I'm going to call this one the team, T-E-A-M, the team parallelogram. And I'm going to choose a color. I'm going to choose pink this time. This one we're talking about parallel sides. Remember that when you have parallel sides, this is the symbol for parallel. It looks like two L's next to each other. And this is how we mark it in our diagram. Here's a single one. This one's parallel to this one. And these are opposite sides, so this one is parallel to this one. So it looks just like the definition. So let's go ahead and write TE and AM. Those are parallel. And EA and TM, those are parallel. Alright, so we've got one theorem talking about opposite sides being parallel. The next one looks like it's kind of set up the same way. So if a quadrilateral is a parallelogram, then its opposite sides are, and this time we're going to call it congruent. Okay, congruent. My orange will work. Okay, congruent symbol. Remember, it looks like an equal sign and then the S. Okay, so that's not very good. Let me redraw that. Oops, broke it. There we go. Okay. So that is my congruent symbol. And I'm going to draw the best parallelogram this time. B, E, oops, sorry, I started up here. B, E, S, T. There's the best parallelogram. And we're going to take our same orange color and we're going to mark, remember to mark sides congruent, we use that little hash mark. So that one's congruent to that one. And then this one, we're going to use double. That one's congruent to that one. Okay, so TB and TB and SE, those are congruent. And then BE and TS, those are congruent. Alright, next we have, it looks like it's the same, but this one's going to change just a little bit. We're going to start off the same. If a quadrilateral is a parallelogram, that means if somebody tells us that it is a parallelogram, then these are the facts that we know. First of all, we know opposite sides are parallel. Now we know opposite sides are congruent. And next we know that opposite angles are congruent. Okay, so this is talking about angles, so I'm going to switch color. It's still congruent, but we're talking about angles being congruent. Alright, this time I'm going to draw math. Another math, A-T-H. And to mark these congruent, we use the arc marks, the little curves. So M and T are opposite from each other, so I'll mark those. And then A, I'm going to mark this with a double one. And H, that's a double arc. Because those two are congruent and those two are congruent. But these are not congruent. Okay, so angle M is congruent to angle T, and angle A is congruent to angle H. And let's just put the congruent symbol. Okay, next one says if a quadrilateral is a parallelogram, then consecutive angles are blank. All right, first of all, let's go ahead and draw this before we go put anything else into it. So what we know, this is going to be, I'm going to call this the fish, F-I-S-H. This is the fish parallelogram. And what I know right now is that this angle is congruent to this one, and this one is congruent to this. I know that because of this one up here. But what this is telling me is consecutive angles. Consecutive angles are the ones right next to each other. So what we're talking about here, we have two sets. We have this set here and this one. So that's a single and that's a double. So there's the red set. And I'm going to color this in with red. And we have the blue set. This set here and this set here. And I'm also going to highlight this with blue. Because it doesn't matter if it's the red set or the blue set, they are supplementary. Okay, so what that means is that the measure of angle F plus the measure of angle H equals 180 degrees, and the measure of angle I plus the measure of angle S equals 180 degrees. Now you're probably wondering, what about F and I? Yes, those two are consecutive also. So a single and a double would equal 180. A single double, single double, single double. All of those are equal to 180. All of those are supplementary. But we just didn't have room to add them. But yes, indeed, they are. So I'm going to highlight these with blue. I'm going to highlight this with red. Okay, there's the red angles and the blue angles. Okay, next. Quadrilateral. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so I'm going to call this one the lamb. Here's my lamb, L. Sorry. L-A-M-B. And what I'm going to pick purple. Here's a diagonal in purple. So I'm talking about diagonals. And here's the next one here in yellow. Now, diagonals, they intersect here, and where they intersect is, I'm going to call that point X, because that makes an X. So I'm just going to say X marks the spot. Now, it says that they bisect each other, and how we denote that in our diagram is we show that LX and XM are congruent with the little hash marks, and we show that BX and XA, those are congruent. Okay, so let's write that down. We have LX is congruent to X, LX, and XM. And we have BX congruent to XA. Okay, so I'm going to highlight those. This one is in yellow. Okay, and this one is the purple one. Okay, here's an example. Math is a parallelogram. So they're telling us up front that this shape right here is a parallelogram. So all of these facts apply. Find the values of W, X, Y, and Z. All right, so in order to find those, we have to use all our facts. So first of all, I'm going to start highlighting. The first thing I know is parallel. Okay, I might need that, so I'm just going to mark these parallels. So this side is parallel to this side, and notice how I'm using the same color as parallel. This is double, this is double. Okay, I may need it, I may not, but I'm going to mark it. The next one is congruent. Okay, and so here we mark congruent sides, so opposite sides are congruent. So this side's congruent to this side's congruent to this side, and I use the same color. Then I'm going to choose green. I'm going to show that the angles, this angle is congruent to this angle. This angle is congruent to this one. Okay, and I might need these, but before I get too colorful here, I'm going to try to see if I can solve anything. So first of all, W, X, Y, and Z. All right, so I'm going to start off with X. Let's see. Oh wait, here's W, and X, Y, and, all right, and Z is over here. So I'm going to start off with X, because X is easy. Look at that. X is the same length. It's this side here, HT, and it's going to match this side, MA. So that's going to be 15. So X equals 15. And I'm going to just underline that in orange so you can see where you got it from. Okay, so that came from this. Congruent sides. All right, next we have Y. Look here. Y, green, green. Y equals 55 degrees. So I highlight that in green because that's where it came from. It was because of opposite angles congruent. And then I've got this one and this one. And I really don't know that much about it. But I have this next theorem here that says consecutive angles are supplementary. Remember the 1 and 2, 1 arc mark, 2 arc marks, they add together to equal 180. Well, here's a single and a double. Here's a single and a double. And we know that both of these are 55, so it doesn't matter which way you go. But you would write W plus 55 equals 180. When you subtract 55 from both sides, you get W equals 125. And I'm just going to outline that one. I'm going to say that one in blue. See, this one was a single and this was a double. Okay, that came from the blue ones. Okay, now there's some information. Remember, we don't ever forget information. So the next ones we have to recall on prior knowledge. So Z, that's an exterior angle here. That's what we're talking about. And this one. All right, opposite angles are congruent. So if this is 125, I know this is 125. And I know that these two, HTA and this angle Z, those are a linear pair. They're supplementary. So let's write that down. The measure of angle HTA plus the measure of angle Z, or I'm just going to call it Z, equals 180 degrees. And that's because they're a linear pair. All right, so I'm going to plug in what I know. I know that HTA, that's 125 degrees, plus Z, which I don't know yet, equals 180 degrees. Now subtract 125 from both sides, and guess what? Z, we've seen this number before, equals 55 degrees. Okay, so I'm going to highlight that linear pair. This was a linear pair, right here in red, linear pair, and that's where that came from. All right, page 2. Page 2, we have an example. Another one, and it says A, B, C, D. When you see 4 letters like this, remember that's quadrilateral. A, B, C, D is a parallelogram. So we're told that it's a parallelogram, so we can use all of our facts. Diagonals AC and BD intersect at point R. So here's diagonal, diagonal, intersecting right there at point R. If AR is 5x plus 1, so I'm going to mark that AR. AR is 5x plus 1, and RC is 3x plus 5. They want us to find the entire diagonal, which is AC. Okay, so our facts tell us about diagonals that they bisect each other. So I'm going to take my purple marker, and I'm just going to put this little mark here because that's how we make sure that we know that those two are congruent. Now that I see that they're congruent, I can set up my equation. 5x plus 1 equals 3x plus 5. Okay, and then this is just algebra part, so I'm going to subtract 1 from both sides. That leaves me with 5x on the left equaling 3x plus 4 on the right. Now subtract 3x from both sides. That leaves me with 2x on the left equaling 4 on the right. And now I divide both sides by 2. So x equals 2. Okay, so now I can find AR. So AR, remember, was 5x plus 1. So I'm going to say 5, put in parentheses, 2, because I'm substituting in the 2 for the x, plus 1. 10 plus 1 equals 11. Okay, the next one, RC. RC is 3x, so I'm going to substitute in my 2, plus 5. 6 plus 5 also equals 11. Now, the reason I did this is just to check my work, to make sure that I got this right. If these two ended up being different answers, that means I messed up here. But really, once you find one, it should equal the other one. Just be careful, because if you make a mistake here, you're going to make a mistake here. Okay, did I answer the question? No. I still have one more step. I know that AC is equal to AR plus RC. This whole segment, that's segment addition postulate. So AC, if I substitute in what I know, that's going to be 11 plus 11. So AC is 22. 22 units. So there's my answer. Okay. Next example. Find the values of x, y, and z. Write the property of parallelograms used for each. That means that you want to write down how you knew the value of each variable. Okay, so here is x, y, and z. This one actually is x. It didn't quite look like it because it got cut off. So x, y, and z. Now, the very first one tells you that quadrilateral is a parallelogram if the opposite sides are parallel. So, I'm going to mark the sides parallel. First thing I'm going to do is I'm going to get a color and I'm going to draw, just extend this side out. This side and this side I know are parallel. Okay? So those are parallel lines. Now remember, parallel lines cut by a transversal, there's my transversal T, then I know certain things about angles that are formed. I know that alternate interior angles are congruent. So that means that x is equal to 31. So I'm going to write down x equals 31 degrees. And I know that, I'm going to highlight that in blue so you can trace it back to where you got it. And it's because alternate interior angles are congruent. Now, before I had alternate interior angles, what property of the parallelogram did I know? Okay, well, I knew that these two were parallel because opposite sides are parallel. So I'm going to say, and opposite sides I was just going to abbreviate, so opposite sides are parallel. Okay. That's the property that I knew. Okay, next. Just like I did before, I had this set parallel. I'm going to choose a different color so I can highlight it in a different color so you can see it. Okay, turn it around. I've got this side here in green parallel to this side here in green. These are parallel. So I'm going to mark them parallel. Well, parallel sides cut by this transversal. I'm going to use the same transversal, but this time it's green. I know that this from green mark to green mark, this arc here, angle, is going to equal this angle right over here. So y is equal to 44. So I'm going to write that down. Y equals 44 degrees. I'm going to highlight it in green so you can trace back to where you found it. And again, it's because of alternate interior angles are congruent and opposite sides are parallel. So it's the same thing, same reason. Okay, next. Z. What do I know about Z? Okay, well, Z is over here, and I've got this angle over here. So I know that Z is going to equal 105 degrees. I'm going to highlight that in red so you can see where it came from. And I know this because opposite angles are congruent. And you're done. So you found the missing variables and you have listed the properties of parallelograms. Next example. Explain why each figure is not a parallelogram. Okay, so if I look at this one, I see that they have diagonals, but I don't see anything marked. And I see angles, but I don't see anything angles marked. So it has to be the sides. I don't see any parallels, so it has to be the congruents. So you take a look and you see that one's 8, that one's 8. So these are congruent, but these are not. Okay, so here, the reason why, it says explain, this would not be a parallelogram because opposite sides are not congruent. And you remember how to write the not congruent symbol? It's the congruent symbol, but with a slash through it. So that's not congruent. All right, next. This one here. I have diagonals marked. And remember, diagonals bisect each other. So this piece has to equal this piece, and it does. But this piece is 4, and this piece is 6. So these are different. Okay, so this is not a parallelogram because diagonals do not bisect each other. All right, and finally, if we look at this one, all I have are angles marked. Okay, so here, it looks like it should be because that's 20 and that's 20 and that's 50 and that's 50. But this is tricky here. Remember the other one where consecutive? If you look at this, this is 1, this is 2. Remember the angle that's marked with 1 and the angle that's marked with 2, they're supposed to add together to be 180. They're not. So here, this is not a parallelogram the way it's marked because consecutive angles are not supplementary. In fact, 120 plus 50 equals 170, not 180. Okay. All right, next page. All right, on this page, we have some more theorems to go through, and this is kind of like the converse of the theorems. Before, we had quadrilaterals and we were told that they were parallelograms, and then we learned facts. Now we have facts and we're trying to prove that these quadrilaterals are parallelograms. All right, so it starts out a little different. It says if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. All right, so if that happens, if you have a shape and it shows that opposite sides are parallel, then you know that that quadrilateral is a parallelogram. In other words, if you have this shape and it is marked like this, then you can call that quadrilateral a parallelogram. But you have to have both sides marked parallel. Okay, now remember, parallel was in pink before, so I'm going to just highlight this in pink and just mark everything so you can see. Try to remember that that color is associated with parallel. Okay, there you go. Now, the next one. Again, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you have some random shape like this and it's marked with single hash marks across from each other and double hash marks across from each other, then you know that this shape is a parallelogram. However, in order for it to be a parallelogram, both opposite sides, both pairs of sides, both pairs of sides must be marked. And that's the same up here. So both pairs of sides must be marked parallel. And this was congruent. Okay, so that one was in orange. So I'm just going to highlight that in orange. All right, so you can associate orange with congruent. All right, next. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so again, if you have some random drawing and you see that opposite angles are marked congruent like this, I'm going to mark them in green because that's what we did on the other side. Alright, so congruent, angles in green, so that's a single, this is double. Okay, but again, both pairs of angles must be marked congruent. I'll put this in green so you can associate that with congruent angles. All right, next. If one pair, see how all of these were both. This one says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Okay, so if you have this random shape, random quadrilateral, and you see that it is marked with this symbol here, and it also has this symbol here, showing that those sides are parallel and they are congruent, then you know that that shape is a parallelogram. So only one pair of sides is marked but it has to be marked with parallel and congruent. It has to have both markings. Okay, there we go. All right, last one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so here's your shape. And you've got your diagonals marked. Okay, so if you see this piece congruent to this piece and this piece congruent to this piece, then, but you have to have both, then you know that this shape is parallelogram. So both diagonals are marked. To show that they're bisecting. Okay. Almost done. This is, oops, this should be a 6. All right, example 5. What theorem can you use to show that the quadrilateral is a parallelogram? All right, so if you look at this one, you would want to say that opposite angles are congruent, but I don't know this. I can find it, but I don't know what it is yet. However, there's another one. Remember, consecutive angles. If I have a single and a double arc, if they add up to be 180, then I know that this is a parallelogram. So here, consecutive angles are supplementary because 150 plus 30 equals 180. Okay, so since these are supplementary, then you know that that is a parallelogram. All right, next. Okay, so this one I have marked as 9.3. Notice I don't have the hash marks, but I say this one is 9.3 and this one's 9.3, so I can put the hash marks. So this one equals, this one's bigger, so this one's equal to this one. And this is 5.2 and this is 5.2, so I know this one equals this one. So, since I show, and I can show that those are bisecting each other, I know that diagonals bisect each other, and that's how I know that that's a parallelogram. Alright, last one. Okay, I only have one side marked, so it's going to be that one, see the only one, and it has to be both congruent and parallel. So I see the parallel mark here, here, and here, but I don't see the hash mark. However, I do have a number, so I can put the hash mark. I know that this one's 10, and this one's 10, so they are congruent. Alright, so I write one pair of sides is parallel and congruent. Okay, so parallel, we'll put in pink, and congruent in orange. Alright, next. Last one. For what value of x is the quadrilateral a parallelogram? Okay, in order for this to be a parallelogram, these two must bisect each other. Okay, so I have to show those were missing. So I have these marked. Single, single, double, double. So the way it's going to be on your quiz or your test is you will not have this marked here. It will be these. They were marked wrong. So you've got these two marked, but these are not marked. But you have these two as marked with algebraic expressions. So what you're trying to do is figure out which x could I plug in here so that these would be congruent, because you want them to bisect each other. So you set them equal to each other. You say 2x plus 5, because you want them to be equal, so you set them equal. Alright, and I'm going to subtract 2x from both sides. And I'm going to get 5 on the left equaling x minus 12 on the right. And then I'm going to add 12 to both sides. And so that means that when x is 17, so let's write that down. When x equals 17, the diagonals bisect each other. Therefore, the quadrilateral is a parallelogram. And we are done.